drop down, snap, After that, you just drop in,
Welcome back everyone. This will be the last update regarding our enemies for a while. I won't keep this intro too long, we got a lot of cover in this video and hopefully the chapters will help you out. Some breaks will be needed, so keeping the chapters somewhat organized is helpful here. And as a reminder, all of the code and assets can be found on my website or on GitHub. If you have questions about this tutorial, or maybe you get stuck somewhere, check out the Discord link. And if you want to go the extra mile to show your support, there is a link below where you can buy me a coffee. Even though I don't drink coffee, I'm a tea guy. Now, let's take a look on our last update and then we can get started with this one. We began last update with moving around some code. It made more sense to keep the switch for the enemy behavior in the Crab class instead of inside the enemy class. Then by making smaller methods from our big clump of code, we can now call individual methods in the enemy class from our Crab class and even later other enemy classes as well, without having to code out the same methods for each enemy once again. So we can reuse our code over and over. We spent some time going over how our enemy will work depending on how and when it sees the player. Then by adding each of these methods one by one and talking about what they do, we had in the end an enemy that when it sees the player, it chases the player and last it attacks him. Now let's head into the combat section of this code. Let's take a look at the current state and see where we're at. So we can start. Player can move around, enemy moves around, perfect. Let's begin by adding our status bar or health bar in other words. And we need an image for that, or rather a sprite. And I have it right here. So this is just the background for the UI, and then we have a bar that we're gonna draw in the game. So we have both for health and power maybe. So this is optional later. We're not gonna work with it, but good to have it and not need it than to need it and not have it. So we are just going to drag it into our res folder. Okay, let's bring it up. And there it is. So let's go to our load and save, just like we do with any other image we add. Let's copy this line, paste it, and status bar. Status bar is a good name. And then of course the actual name, which is health power bar. It's good. And we're going to add this image inside our player class. Maybe we could have it in our playing, but it will only care about the player. So you know what, let's keep it in here. So let's make some room here and say status bar UI. And I'm gonna copy paste a couple of lines here and you'll see why. So we first have the actual buffered image, and then we have position and size of the actual bar, the actual image. Then we have position and size of the actual health bar, the little red bar that's gonna change in size depending on the health of the player. So you can pause the video and just copy down this and then continue once you've done that. But let's import the image, and we're going to import the image in the same method where we load the other images for our player. So at the bottom we say status bar image is equal to load save dot get sprite atlas load save dot status bar. So now we have the status bar. Perfect. So with this bar now in the game, let's actually try and see how it looks in the game. So let's find our draw method. Here we have it. And let's call draw UI. Let's create the method. We don't need level offset. We're gonna have this image stuck in the top left corner of the window. It will always be on the same size. So no level offset is needed here. Then just g.drawImage. And we're gonna select that one. Status bar image, yes. Status bar X, status bar Y, status bar width, status bar height. All right. And if we give it a try and see how it's going to look. Alright, so we have it in the top left corner. Beautiful. Now let's work on getting the health bar visible and also change in size and how that's going to happen. And for us to be able to display the health bar in different sizes depending on how much health the player have, we're gonna need two variables to begin with. We're gonna need a private int max health, meaning this is the health that the player starts with whenever the game starts or whenever a new level starts. So we're gonna set it to 100 for now. We can change it later, but let's play around with 100. And then of course we will need the current health, which will be starting at max health. Like so. And we can actually use one more variable just to make it a little bit cleaner in the code. So private int health width, we're gonna call it, and we're gonna set it to the health bar width as a start. So they have the same values at the start. But as soon as the player starts losing health, this one shrinks. And we're gonna update that one inside our update method. So update health bar. And let's create that method too. And all we're going to do here is to say health width is equal to, we're gonna have to recast this, and we're gonna take the current health divided by max health and then time it health bar width. And what this calculation is going to do is going to take the current health divided by the max health, and we will now have a float. And if we had 50 health divided by 100, then we have 0.5. So 0.5 times the health bar width will now become a health width that is half of the original size. But it's not complete yet. We actually need to cast this one over to a float. We need to set one of those to a float, otherwise this one will be an integer, so it will be either 0 or 1. Will never be any float values. So we need to set one of them to float, and actually we can add one more parenthesis here just to make sure. Something like this. So now let's draw the bar and see what happens. So in our draw UI, we say g.draw, or rather set color, we need a color first, color.red. And then we go g.draw, fill rect. We're gonna start at health bar x start, health bar y start, health bar width, we're gonna change, and health bar height. But we're going to add, for the x and y, we're gonna say plus status bar x. So this is the offset. So this value right here is the offset in the image. So all we have to do is to keep this offset and plus the status bar x, and now they will move around wherever the status bar is located. And then for y we have the same, so plus status bar y. And for width, let's change that up. Take the health width variable, place it in the bar. Let's give it a try and see how it looks. Perfect, now we have a health bar inside our image there, or our status bar. But let's give it a max health, or rather health, of say 40. So we have lost 60 in health. Let's see the size of that bar. Look, the size of the bar changed now with the player losing health. So we know now that that is working. But before we leave status bar for a while, let's add one more method right underneath our update x position. Doesn't really matter where it is. We need a method that can change our current health. So public void change health, and it's going to have int value and health minus equal, or rather plus equal value, because it could be positive or a negative value. Maybe we want to increase the health, maybe we want to decrease the health. And what we need to check here is if health is less than or equal to 0, then we're going to add two brackets here, or brackets here, and say health is equal to 0. Isn't it health? It's current health, right? Current health. Yeah, that's my bad. So current health is equal to 0, and then we want to say game over. But we have not added that one yet, so let's just keep it there for now, comment out. Or if current health is more than or equal to max health. I can't spell, that's okay. Then we say current health is equal to max health. This just makes sure that we are not going under 0 or over the maximum health. And I think that's all we need to do for our status bar for a while. For us to actually be able to attack the enemy and the enemy to attack the player, we're gonna need some more hitboxes, or rather attack boxes. And let's go to the top here in the player class. Right underneath our status bar, everything, we say attack box. And we're gonna add a new private rectangle 2d.float, and we're gonna call it attack box. And this attack box will simply be the area that whenever the player clicks attack and attack is happening, if enemy is inside this attack box area, then the enemy takes damage or dies. Init attack box right underneath here. So let's create the method. Attack box is equal to new rectangle 2d.float, and the values, let's see what I came up with. They are x and y, we're starting at the same position, but we are setting the width to int 20 times game.scale, and then for y we add the same, so 20 times game.scale. So there will be an offset for x and y, but we're gonna add that in our update, because as soon as we start the game, we're gonna do update methods, and so in here we will have those offsets being applied to our attack box. So let's add that right away. After update HealthBar, we say update attack box, then create that method. And in this method, we are actually going to check for left and right. So if right, then we're gonna set it to one position, else if left, we're gonna set it to another direction. I know that if we are running to the right, this one comes true, so our hitbox will be on the right side of the player, but as soon as we let go of the key, we're not updating here anymore, but at the same time, we don't have to, because we're not moving and we're not changing directions. We say attackbox dot x is equal to, and we're gonna tie it to our hitbox dot x, so there will be a correlation. Wherever the hitbox of the player goes, attackbox will follow with some offsets. So plus hitbox dot width, because we need to move from the left side to the right side, and then we have our actual offset will be, which will be int game.scale times 10. And we might as well copy this. And for the left side, we do the same thing, but minus hitbox width and minus that. And then we update the attack box for y as well. So attack box dot y will be equal to hitbox dot y, but a little bit down, so plus game dot scale times 10. So it's 10 all around. All right, that looks good. Now let's try and draw it. So let's go to our draw method here. We have our current hitbox, but let's add draw attack box. And here we will need G for graphics and also level offset, because it needs to follow along the player. And then we create the method. First we need to set the color, so g.setColor, color.red, and then we say g.drawRect, attackbox.x, attackbox.y, attackbox.width, attackbox.height. And we need to have it for an integer x, y, width and height, but x also needs minus level offset, or rather level x offset, maybe we should call it level offset x, level offset X. We know what it is for anyways. Doesn't really matter too much. Alright, so let's try and see if we have an attack box around our player. So we have the attack box to the right, and if I move to the left, it's on the left side. But the player is still attacking to the right direction. So let's get that changed too. Before we go and change how the player looks, depending on what direction he's running, we are going to change our player sprites. Right now, this is our current player sprite atlas. We have idle, we have running, we have jumping, falling, and this one we don't use, which is hitting the ground. As soon as we hit the ground, we're supposed to use this, but we don't need that. That's too much work, so we're not using this one. This is hit, the player getting hit, which we are also not using. We are not using the attack number 2, attack number 3, because they are for when you're jumping and attacking in the jump. It's going to be a lot of work just to get those images and sprites working, and then with the hitbox. So we're going to skip those two. We're just going to have one type of attack, and it is this one right here. So let's get rid of a few, and let's change up how the player looks when he's getting hit, and also when he dies, because we do not have a sprite animation for dying. So the one we're going to use now will be this one. So we have most of the same. We have idle, we have running, we have jumping, falling, then we have attack, then we have getting hit, and then we have dying or death. So we're going to go from this to this. And all you have to do is to update or grab the new sprite atlas from GitHub or on my website. So let's just drag the new one into our rest folder. Drag and drop. Okay, and it's gonna override platformer. Yes. And then we need to do a refresh, otherwise the program is not gonna realize, there's a new image with the same name. So a refresh is usually needed. Then we need to go to our constant class, where we have the player somewhere. Here we have the player. So we removed attack, jump 1 and 2. We'll remove ground. We will keep idle, running, jump, falling, hit, and attack. And then of course we will have a public static final int dead, which will be equal to 6. So 0, 1, 2, 3, 4, 5, and 6. And then we need to change up a little bit here. Let's go from the top and add them one by one, or check them one by one. But the first one we will have is case dead return 9, right? 1, 2, 3, 4, 5, 6, 8. Nope, 8. Not 9, but 8. Running is the same, idle is the same, hit is 4, correct. Jump and attack, well, jump is 3 and attack is 3, so we will say return 3. Falling is still 1 and default 1. So 1, 2, 3, 4, 5, 6, 7. That matches, so that is now looking correct. Good, so we can close down constants for a while. Now we need to do a quick change in our player class, where we load images here. So instead of saying 9, 6, we're gonna say 7 and 8. So it's gonna be 7 and 8. And just to see that it's still working, let's start it up. So the player runs like normal, back and forth, jump, up and down, falling. Yep, that looks good. Attack. Attack is a little bit off. Why is that? And that is because our attack 1 should not be the number 5. It should be 4. And hit should be 5. So let's just grab one of them and move it into correct position. 5. And we can probably just call it attack rather than attack 1, and now just change whatever errors appear. So attack, not attack 1, because we only have one attack. And then in our set animation, attack, and now it should work flawlessly. Still running correctly, jumping, attacking, beautiful. And falling, yeah, that looks good. Perfect. To get our player sprite and also the enemy to change the direction it's looking, there is two ways of doing this that I know of. This is one way of doing it. That's actually the way you're supposed to do it. And then with it you can also translate, which is fancy word of saying moving it around. You can also flip it and you can also scale it. But going into what all of this is doing is going to take a long time to explain, and that's not the goal of this tutorial. The goal of this tutorial is to find the simplest way of doing things, and then the individual can improve on it. But we're not going to do this one, even though it's the preferred way. We're going to do it by just simply saying negative width. And what that is going to do is that, say you have a square you want here, x, y, and then width, and then height. But if you gave it the negative width, it's not going to go to the right. It's actually going to start in the same position here. But since you gave it a negative width, it's going to be drawn to this side. And it's going to have the same width, but in the opposite direction or the left direction, but it's going to still have the same height. So if our player was here with just a normal width, and now we used negative width, he's going to be on this side, because we started here and then we go to the left instead. But all we have to do to compensate for that is to go for x position plus width. So now he's facing the left direction, even though he's in the same position as if he were using a normal width. So let's get that going. And to do that, we're gonna add two more variables. So up here we say private int flip x equals 0. Private int flip w equals 1. And you're gonna see soon why we set this one to 1. But let's go to our update position where we check for left or right. We're gonna add brackets to this. So if we're going to the left, then we want to say flip x is equal to width, the actual width that we are drawing the player. And for our flip w, we want to say is equal to negative 1. And if it's the right direction we're going, then we want to say flip x is equal to 0 and flip w is equal to 1. And with these two values, now we can go to our draw method where we draw the player. There is the image, here is x, there's y, and then we have width and height. So for our player x, we say plus flip x. And for our width, we say times flip w. So if we are going to the left, flip w will be -1, so it will be width times -1, which will be negative width. And if we were going to the left, flip x will be plus width. And that is how we add the offset now when the image got flipped. And if you're going to the right, then flip x is going to be 0, flip w is going to be 1, so width times 1 is still width. So let's give this a try and see how it looks. So the player falls down, going to the right, that looks alright. And if we go to the left, poof, now the player shift direction. Simple, yet just as effective as a fine transform. Beautiful. So now you see that the hitbox is in the middle of where the sword hits, as well as on the right. And now let's add the same for our little crab. Underneath our update move, we create two methods called public int flip x and one called public int flip w. They're gonna do the same, but we don't need to add it in any method. We can just check if walk there is equal to right, because the Crabby is facing to the left by default, so it's the right one we need to add for or change for. Return width, else return 0. Isn't it right? Or don't we have it? We might not have it. So import static utils.constant.directions, and let's grab them all. How about that? Yeah, that works better. And for flip W, we check the same. If walk there is equal to right, return -1, else return 1. And then in our enemy manager, where we draw the enemies, for our crab, there is the image, there is the X, there is the Y, and there is width and height. So for X, we say plus C dot flip X, and for the width, we say times C dot flip W. And now we try it, and the enemy should face the direction he is going. So to the left and down to the right. Let's follow him a little bit to see the difference. So chase me, looking kinda to the left, looking kinda to the right. That is beautiful. Just like we added a hitbox, or rather attack box, for our player, we will now do the same for our Crabby. So let's just grab this and copy, attack box, go to our Crabby, and at the top here we say private rectangle float attack box. And you know what, let's add some offsets right away so we don't have to calculate them each update. Private int attack box offset X init attack box. Let's add that method too. So attack box is equal to new rectangle 2d.float, and the values we're gonna give it are X or Y, because it's gonna start in the same position. But the attack box for the enemy is actually going to be a long rectangle that crosses from the left of the enemy to the right of the enemy, because when the crab attacks, he shoots out his claws in both directions. So we're just gonna make a long rectangle from left to right of the player, or rather the enemy, and that is going to be our attack box. So the width will be recast over to int, because we're using scale here. Important. We say 82 times game.scale. And for height, we are actually going to do the same height as the enemy itself. And we now need to calculate the X offset for the attack box, which is equal to, recast over to int, game.scale times 30. So it's going to be 30 on the left side, 30 on the right side, in size, in width, and then 22 in the middle. So that's where 82 comes from. 30 plus 22 plus 30 is 82. Should we also maybe add a update method for our attack box? So let's add that right underneath our update animation tick. So update attack box. And let's create that one. So attackbox.x will be equal to hitbox.x minus attack box offset X, and then attack box Y equals hitbox Y. Simple as that. And now let's actually draw the hitbox, or rather attack box. But we don't draw anything yet in Crabby. It's inside our enemy manager. We just send the values there, but the attack box for Crabby will most likely be way different than some other one. So let's just add a draw method in Crabby. So let's go down here. Public void draw, then graphics G, and we're going to not draw, but we're going to call it draw hitbox. Draw attack box. And of course we will need int X level offset. So g.set color, just like before, color.red, g.drawRect, not fill rect, draw rect, and it will have AttackBox. Oh, my bad, what happened? AttackBox.x, AttackBox.y, AttackBox.width, AttackBox.height, and negative or minus x level offset. But we need to cast them over to ints. So, just gonna copy this because I'm lazy. In front of that one, in front of that one, and in front of that one. No errors? Great. We're updating the position. Yes, we are. And it's correct right there. Yes, it is. So let's go to Enemy Manager, and where we have draw crabs, we have the normal hitbox, but let's just say c.draw attackbox G level offset. Save it, and let's give it a try. So that is how the hitbox is going to look for our enemy, or rather the attack box. So if the player is inside this hitbox anywhere, even here, he will take damage. Yeah, that looks alright. We can change the sizes and all that later, but for now, let's just get it to work, and then you can polish it up as much as you want. One thing we will need is a GameOver class, and that one will be for whenever the player dies. So let's just go ahead and add it real quick. So for our UI package, new class, and we're gonna call it GameOverOverlay. Just like pause overlay, but this one is gonna be called GameOverOverlay. So it's not the best name, but it's alright. So I'm quickly just gonna make this class. So public GameOverlay, the constructor will take in a playing object, private playing, this.playing equals playing, import the class, because it's going to be made in our playing class. Then we just give our GameOverOverlay a playing object. So we will need a public void draw graphics G, and we will need a public void key pressed actually, and it will take in a key event E. Let's just import them, key event E of course, and then import that one too, like so. And for our graphics, or rather our draw here, I'm just gonna copy some lines here. It's quick, you can pause it just to see. But we're setting the color like so. So it's setting a color black, but it's not completely black. It have 200 in the transparent value. And we're making a rectangle from the top left to the bottom right. And then we set the color to white, and we draw two strings. One that says game over in the middle, and one that says press escape to enter main menu. So in our key pressed, we will need a if e.get key code is equal to key event dot vk underscore escape. If that's the case, then we say we want to add some brackets here. Playing dot reset all, meaning we're going to reset the player, the level, the enemies, and everything. And then we just say game state dot state is equal to game state dot menu. So before we go to the menu, we reset everything, but we don't have this method yet. So let's just quickly make it in our playing class, whatever it is. Don't have it. There we go. So at the bottom here somewhere over key press, mouse click, draw clouds. Here we can say public void reset all. And this is the method where we're gonna to do, can you say reset all. Reset player, enemy, level, etc. So we're gonna get to this a little bit later. I just need a method there as a placeholder. So that's all we need to do for our GameOverOverlay class for now. We just need it there, so when we die, we can set it to game over, and if it's game over, then we show this actual class. So we draw whatever in here. So now, let's work on the combat system. And to get combat working, well, our enemies need some health too. So right over to our constant class to begin, and find our enemy section, which is here. Enemy constants, enemy type, get enemy sprite, right? So right underneath here, public static int get max health, because we need to return a max health for whatever enemy type we have. And if we have a lot of different types of enemies, we might as well just call this method and just give it int enemy type. So a switch is needed, switch enemy type, case Crabby, because Crabby is all we have right now, return, say, 15. Doesn't really matter, or return 10. Default, we return 0, or rather 1. So now we can call this method and get the max health for whatever enemy we might have. Into our Crabby, or rather enemy, we're gonna add protected int max health is equal to, or rather nothing, and then we're gonna add protected int current health, and our max health is equal to get max health enemy type. So, and then of course health is equal to max health, just like the player, but we do a, not health, but current health is equal to health, just like the player, but we need to call this method because we might have different types of enemies. Just like the Crabby have now health, he also need a way of dealing some amount of damage to the player. So back to our constant class, right underneath here, public static int get enemy damage, or DmG. It's gonna do exactly the same, so we might as well copy here. And then switch statement we return, and if the Crabby is doing some damage, we say 15. Otherwise, we say 0, they don't deal any damage. Then that. And we had an extra bracket like that. So now, no errors, and now the enemy can do some damage. So if the enemy's attack box overlaps the player's hit box, now the enemy hit the player, so the enemy calls get enemy damage, and this value is sent to the player's ChangeHealth. But it could also be the other way around. The player attack box overlaps the enemy's hitbox. Then we need some way of going from the player to the enemy and dealing damage to the enemy. And we're going to add a method in our enemy manager, public void CheckEnemyHit. We're going to need a hitbox, but let's be lazy and just go to top of the player and grab it, AttackBox, then go to enemy manager back again. We're gonna ask for AttackBox for Crabby, C and Crabbies, right? We're gonna check if AttackBox, and with this rectangle we have a couple of methods that we can use right away to check whether or not we hit another hitbox. So intersects that one, and then we ask for c.get hitbox. So if that returns true, we did hit an enemy, though those boxes overlaps. We say c.hurt, and we give it a value. Let's say the player deals 10 damage. We can change this later just to check if it works. Like so, and then we return, because the player should only be allowed to hit one enemy at a time. Otherwise, we're testing for every enemy, even though they might be far off. So first we're just checking if it intersects an enemy whenever it attacks. And this hurt, we're gonna put in our enemy class because we can hurt every enemy. Bottom here, right underneath our new state, we add public void hurt int amount, and then we say current health minus equals amount, and if current health is less than or equal to 0, then we want to say new state, and we're going to pass in dead, else new state hurt. So these two we haven't used, is not called hurt, it's called hit maybe. Hit is the one, right? Let's take a look. So we're idle, running, attack, hit, and dead. So if he dies, then we set the current state to dead and do one animation of that. Otherwise, we do the animation of hit. But we're not going to get into hit in this episode. That's one for polishing, and it takes a lot of code to get it to work properly. So we're not going to do hit. We're always going to kill the enemy with one attack for now. But when we polish the game, we can work more on this hit animation. So what should happen then after one animation of dead? In our update animation, we're only going to do one animation of both hit and dead. So we can add a else if enemy state is equal to hit. Then we also want to say enemy state equals idle. Else if enemy state equal dead. So then we just want to say active, which we don't have yet, equals false. So let's just add this one right away. Active is a Boolean, and we're going to place that in our enemy class. Perfect. Protected Boolean active, and we're going to set it to true because the enemy is active as soon as we spawn and start the game. And then we're going to need a getter for this one, and I'm going to get to the point why we have it. But a public Boolean is active, return active. So now we can check whether or not the enemy is active or not. But let's go back here. This looks bad. We have two different states that returns idle, one that sets active to false. It doesn't look very good. So we're going to use a switch, but a modern way of switch. It's still going to do the same, but it's going to look a little bit better. Enemy state. We're going to have the brackets, but we're going to say case attack, comma, hit points to enemy state equals idle. No return, no breaks. And then case dead points to active equals false. So we have this now instead of this. So this, in my opinion, looks much better. Now, what is this all about? Active equals false or true. Well, when you start a game, all enemies, in this case, starts alive. They are running around, they're active, they're doing patrol, trying to chase the player, whatever. But as soon as some of them die, you don't want to update that enemy anymore. You don't want to draw it. Well, maybe you want to draw the corpse of the enemy, but for our case, we don't even want to draw it. So as soon as they're dead, they're no longer active. We don't want to update them. We don't want to check hitbox with them. They're like gone. They're still in the list that we are using to draw everything, but we're skipping them every time we want to draw them, update them, check for hitbox, etc. So in our enemy manager, for every loop we have Crabbies or enemies, we're going to have a check. If the enemy is active, then we continue. If it's not, then we leave it. So let's start from the top. But here we want to make sure that if c.isActive, it is active, then we update it. If it's not active, then get out. So here, when we draw the crabs, let's just move the bracket down. We say if c.isActive, then we draw it. So we put that there. So now we are updating or rather drawing the crab if it's active. And here where we check the enemy is getting hit, we do the same. If it's active, then we want to check it. If it's not active, no point in checking it. And that's all the loops here, correct? Checking hit, updating it, and drawing it. Yeah. So that's why we have active. When the enemy attacks, when are we going to check whether or not it hits the player or the hitbox is touching the player or hitting the player? We're only going to do it once per animation. So we're going to do it at a specific index where the attack looks like it's doing the actual attack. So back to Crabby class, because it's going to be specific for each individual enemy. Some enemy is going to have the attack animation at index 4, 5 or whatever. But in our Crabby here, first let's change the name to update behavior, because we're not updating the move anymore really. We're doing the move here, but it's more that we're updating the behavior. So change it to update behavior and then update behavior there. So it's a better name, but just something that bothers me. So we have behavior for idle and running. Now we have case for attack, break, and then case hit, break. So for our attack, and in the case of the crab, the actual index we're going to check whether or not the enemy is hurting the player is for if animation index is equal to 3. And we haven't checked in this loop before, so attack checked is false. This part right here makes sure that we're only checking if we're hurting the player when we are at animation index 3. This one makes sure that we only do one check per animation. So this attack checked can go to enemy actually. We can keep it here. So protected Boolean attack checked equals, we can keep it like that. Now back to Crabby. And if we haven't checked, then we say check enemy hit. And then we pass in player variable. We have it from there. So we create this method. But it's not going to be inside our Crabby either. We're going to take it, place it inside our enemy, right here for next to hurt. So instead of private void, we're going to say protected void, remove that. So in here we say if AttackBox, that's correct. We can't, the AttackBox is in Crabby. You know what? Let's just attack box and the player to that method. So let's go up here, copy this entire line. So, and then like so. So now we're passing in attack box and the player. So if attack box dot intersects player dot hitbox. So our attack box intersects the player hitbox. And if that's the case, we say player dot ChangeHealth, and now we need the damage from the Crabby, and we have that in get EnemyDmg enemy type that we added before. Let's see if it all works. And the last thing we need to do is attack checked. We might have hit the player, we might not have hit the player, but we did a check, so we say attack is checked is true. But we need to reset attack checked. And we can do that by going to the top here and saying if animation index is equal to 0, attack checked equals false. And this just makes sure that every time we restart the animation, attack checked is false, or rather resets to false. So now we can check and do it only once per animation, and then we can reset it every time we attack once again. And now we did that check for the enemy. Now we need to do exactly the same, but for the player. So to our player class, and in our update method here, right after updating the position, we say if attack, or rather attacking, we say check attack. And this check attack, let's create it real quick. And in here we want to do the same check, make sure that we are on the correct sprite index and also that we haven't checked before. So first we're checking if attack was checked or animation index is not equal to 1, because we're going to do the check when the animation index is at 1. And we need that variable up here, so let's add it right underneath here. Private Boolean attack checked, and it's going to be false from the start. Yep. So if that's true or the index is not 1, then we want to say just return this, leave this method. But if attack checked is false and the animation index is equal to 1, then we want to check it. Then we say checked, or rather attack checked is equal to true. Then we want to call playing dot. We don't have access to playing. That's true. We need it now. So in our constructor here for our player, x, y with height, and then we ask for playing. Then we create a private playing. And right after super, we say this dot playing equals playing. And they want us to import the class. I can do that, like so. And now we have access to the playing. So playing dot CheckEnemyHit. And we want to pass along the attack box from our player. So let's create this method and solve the error in playing by just going up here, player error. At the end we say this. And we need that DmgCheck method. Where can we place it? Let's place it here next to ResetAll. So public void CheckEnemyHit. And in here we're just gonna pass it along and say enemy manager dot CheckEnemyHit. And that's right, we need AttackBox. Player copy, playing, CheckEnemyHit, AttackBox, pass it along, and now we're in here. This method is already made from before, so we don't have to create it now. But I think that in our playing, where we check the enemy getting hit, that's not in there. It's in Crabby, CheckEnemyHit. We say ChangeHealth, and then we get the damage from the enemy. But in the player ChangeHealth, we have int value and then plus equals. So we need to go to our enemy class, or CheckEnemyHit, and set a minus get enemy damage. Otherwise, we are only going to increase the player's health every time the enemy hits the player. But back to our player class, we have yet added a way to reset attacked checked. So to our update animation tick, and as soon as we're done with an animation, we can also say attack checked equals false. So we're setting it to false right in the update animation tick. So let's just start the game and see where we're at. And I know something we need to change right away, or we'll change this in a second. As soon as I click attack, or when I'm attacking, the attack is not coming instant. And that's because we have 3 sprites for our enemy attack. If we take a look, we have 0, 1, and 2. But we should start on this one, the second sprite, to make the attack feel more responsive whenever we are attacking. So as soon as we're attacking, we're going to set the sprite to 1. And the way we're going to do that is by going to our set animation. And somewhere here we have a if attacking, well, set it to attack. But we will add 2 brackets here, one for that one and one at the bottom. First of all, if we're attacking, we're just going to make sure that we are in the correct sprite. So player action equals attack. We're not going to change that. But then we're going to do a check here. If start animation is not equal to attack, meaning that we weren't attacking when we entered this method. So the attack now is new. It's the first time we enter this method since we clicked on our mouse. So the start animation was not equal to attack. And that means we're going to add 2 brackets here. We're going to say animation index is equal to 0. And animation tick is equal to 0. My bad, animation index is equal to 1, because that's what we're going to start. So we do a reset animation tick in here, but we set the index to 1 instead of 0 here. So That's why. And just to make sure we don't go to that part, we say return. And the next time we enter here, start animation is going to be attack. So we will not enter this section. So we will continue like normal. Now let's give it a go and see if that feels a little bit better. Yeah, that's a quicker response when I click. Now we can try and test the combat system. But first, in the player class, if health, or the current health, right, is less than or equal to 0, meaning, oh, he dead, we say playing dot set game over true. And we need brackets here actually, because it's going to be 2 lines. And we also say return, because there's no point in updating anymore. The player is dead, so go to game over screen. So in our playing, we're gonna add a public void set game over, Boolean game over this dot game over equals no equals game over. It's not the same as the game over overlay. It's gonna be a boolean, so we're gonna add a boolean here. Private boolean game over is gonna be false by start, and then at the top here we need to add the game over overlay. So game over overlay, game over overlay. And we need to initialize that class to right after our pulse overlay. So GameOverOverlay equals new GameOverOverlay this. And now, whenever we die, we wanna draw the background, draw the clouds, draw everything. But if we are not paused, else if game over, then we say game overlay dot draw. So now we draw whatever inside here. And let's do this check also on other places. For example, if we are dead, we can't attack. So if game over, or rather if not game over, we do this. Let's add that instead. But for our key pressed, we say if game over overlay dot key pressed, else we can do the switch. But for our key released, if not game over, do it. For our mouse dragged, we add a if not game over, and for our mouse pressed, we add the same. Mouse released, mouse moved, unpause game window for that's okay. We don't need any of that. So that's all we need, I think. Now comes the very, very fun part. Testing if it works. We won't be able to loop yet, but we might go to game over screen and then menu, and then we close down the program. But we're gonna add the reset function in a second. Let's just see if we can kill the enemy and get killed by the enemy. So let's start it up. Working so far. Let's try if I can kill the enemy. Let's see what happens. Come here. Enemy died. I'm still running around. Perfect. Let's set health to 100% first, or 100. So player health, current health equals max health, like so. Now let's see if the player can get killed by the enemy and what happens to the health bar. So I'm just gonna stand here, took damage, etc. Let's see what happens if I die. Poof. Press escape to enter menu, and why is it only half the width? And if I press escape now, will I go to the menu? Maybe, and this needs to be fixed too. We should draw the player, or rather draw the enemy, but we shouldn't update the enemy. Alright, escape. Alright, it works. But let's take a look why it was only half. And that's because it says game height as width, not game_width. That's better. And let's take a look why the enemy kept updating even though we were dead. So if paused, we update the player, we update the enemy. We should not do that. We just and not game over, like so. What about draw? We fixed draw, but we never fixed update. So let's give it a try again and see what happens when the enemy kills the player. So kill me now, please. Come on, come on. Boom. Enemy stops animating. The health bar didn't actually update, but it looks better here. Game over, press escape to enter main menu, and I did. Beautiful. Let's just switch those two methods in player class, because we check if the player health is less than 0, which it is, but we never update it, so we just place that at the start. Now the health bar will be updated, it will say 0, and then it comes down here and also checks, it's 0. So game over, please. That's all. Now we're gonna work on resetting everything and be able to loop. Like we die, we go to menu, and then we come back. So to our playing class, we had a ResetAll right here. We're gonna have a GameOver equals false. We just want to set each Boolean to the original values and reset the position of the player and all the enemies. So if the Boolean was false when we started the game, it should be false now as well. So GameOver equals false, paused equals false, just to make sure it doesn't accidentally get true. Then we want to say player.resetAll. We want to say EnemyManager.resetAll enemies. We don't have those methods yet, but we want to just have them right there. So let's begin with the player. Create method ResetAll in type player. So in here we want to set reset direction booleans, left, right, up and down, etc. We also want to say in air equals false. We want to say attacking equals false. We want to say moving equals false. I have a little cheat sheet here on my other screen, so I don't have to look it up. I know it's going to work because I coded this before. And we want to say player action equals idle. And we want to say health is equal to max health. So we're setting health as well. We also want to reset. It's not health, it's current health. That's better. And we also want to reset the position to the starting position when we started it. It will of course be different from each level, but when we add more levels, we're going to have a variable that says here is the player's going to start, or rather here will the player start, here will it start in this one, and here in that one. So we just want to reset it to the values that we gave it when we initialized the player. And we still have it actually. It's stored in hitbox.x is equal to x. So we still have x and y, but we never use them. So they can be used as a reset value, which is very neat. And then hitbox.y equals y. And we need one more check here. Exactly the same one we have. Load level data. Where we load the data, we also check if the entity is on the floor. Then we say in air equals true. So we're just going to copy that and place it here or paste it here. And that's all the reset we need to do for our player at this stage in the game. So we've done it for the player. Now let's do it for our enemy. So in Enemy Manager, we wanted it something called public void reset all enemies. And we are just going to do a for loop here, enhanced for loop. Crabby c crabbies c.reset all, or rather reset enemy. And we don't have to check whether or not the enemy is active or not. We're gonna reset all enemy. And I think we can have it in our enemy class as well. So right here we say public void reset enemy. And we wanna say hitbox.x equals x. Hitbox.y equals y. First update equals false, or rather true actually, because we are in the first update now. Then we want to say current health is equal to max health. And we don't need to get the max health again, we already stored it. And then new state equals idle. I'm going to set it to idle right away. And then we want to say active equals true, which is very important. And then, of course, fall speed equals 0. So if we start falling down, we don't want the fall speed to continue from what it was the last time we stopped falling. So that needs to be reset as well. And I'm pretty sure if I start it now, we can go kill the enemy or be killed by the enemy, restart it, and it should all work. But before we do that, I'm actually going to add a few more enemies just to see if I can kill a few and someone can kill me. And then we can restart it. All enemies are now back. So the level data here, selecting that one, the color of that one, which is the enemy, so I can just copy it. Add 2 more enemies here, 1 there and 1 there. So 5 enemies in total. File, overwrite it, and since we messed with a res folder, let's do a refresh here. Start it, and hopefully we should have 5 enemies in the game. And we do, but let's get rid of the hitbox, that looks terrible. So the player hitbox we can remove or comment out, we don't need to remove the code. Draw a hitbox, no thank you. And in the enemy manager, wherever we draw the crab here, draw AttackBox, no thank you. And let's start it again. That looks much better. So we have a lot of enemies, as you can see. They are all patrolling, checking each, and it's looking, I mean, it's starting to look like a real game. Did we have a bug there? Oh yeah, we did. Nah, nothing to care about right now. It's still working, so I know how we can fix it, but it's not important. He can hit me, I take some damage, I can kill him. Can this one hurt me? Oh, we had a bug there. Sometimes you find bugs, so we need to check this one later. It's a small bug, but it's not hurting me, which is good, but that's an issue. We need to fix that later, for another episode maybe. But let's see if I can kill this one. Yeah, I can kill him on the left side and I'll kill them on the right side. So let's jump over here, and I died. And let's see here, we have 2 more enemies. Let's kill one. I'm gonna let this one kill me, and then we're gonna go to the game over. The health bar is 0. I click escape, and if I click play, now will everything work? The player direction changed, that's the only difference I see. But they are walking and patrolling like they did. Let's jump up here. He can still hurt me. I can still kill him. I can kill him too. I can jump over here. Can kill this one. And now there should be 2 more enemies. Right? Yeah. Let's see if they both attack me at the same time. Oh, I died quick. So back to menu. Play again. And yeah. It's working. Yeah, so it's working. We have a functioning Gameloop, if you want to call it, or we can die and go back to menu and then play again. Beautiful. There's a few bugs that we need to deal with, but we'll take them another time. Wonderful. Oh boy, is it over? Yes, yes it is. For now. We started the first part without any enemy in the game, and now we got enemies that can attack and kill the player. That's a long way to go. We can go from game over to try again, over and over. If you've gotten this far, you should feel proud. It was a lot of code. Well done. There is of course much that can be improved from these updates, but we will spend time and energy on polishing it later. First, get it to work as you want it, then you can work on polishing the game. No matter how long you polish a piece of crap, it will always be a piece of crap. Now, go have a Swedish fika, you deserve it. Until the next episode, my friends, take care now and have a wonderful day. Bye.